Welcome back. I hope you had fun and I hope you are now happily munching on Reese's Pieces. So, what I'm going to talk about the next few minutes is probability sampling. And it's sampling techniques that fall into the family of probability sampling because we use the laws of probability. So, these sampling techniques rely upon randomness to make sure that we have the most unbiased sample possible. So, probability sampling helps us avoid sampling bias to the best extent that we can. So, the first type is called simple random sampling. And how simple random sampling is, you must identify all members of the population. So everybody has a chance to get involved. And every member has an equal likelihood of being selected. And of this, I'm going to give you two good examples of random sampling and one bad example of random sampling. So the one good example is if we want to know every homeowner in Honolulu. So we go to the county book of records and we get pull out the names of every homeowner from Honolulu. And then from those names, we randomly select 100 that we want to participate in our study. Okay, in that case, we were able to identify all members of the population. So we can do simple random sampling from that population. We can draw from all the homeowners, our list. We can take 100 people out of there to get our questionnaire, our interview, or whatever we're doing in our study. The second example of simple random sampling is all students at UH Manoa. I could go to the registrar and I could get a list of all students. This is purely theoretical. They wouldn't let me have a list due to privacy laws, but let's say we could. We could get a list of all of the students, and then we use some mechanism to randomly select the number of students we want to get opinions from about whether they use the rec center or not. So in this case, it's a really good sample because every single person, every single student at UH Manoa is included because we've identified them all and they're in our population. Okay, now those are my two good examples. I have some way to get the names or identities of everybody in the population. Now, this has been a problem lately, especially as cell phone use goes up and up and up, and landline use goes down and down and down. When I was growing up, all we had were landlines, so everybody had one, and that's how we used to get a hold of each other. Now, I don't even know if I know. I mean, my older relatives have landlines, and some people for weird circumstances, but most of us have cell phones. So let's say I go to the phone company and I get all of the numbers from everyone in the country, and I do random digit dialing of those numbers to find out who they're going to vote for president. Okay, so I call everybody. I pick 100 people on that list that was chosen by random digit dialing from the phone company, from everybody that has a phone, a landline in the country. And from that poll that I took 100 people from that list and I asked who they're going to vote for president, I project who's going to win the race. Well, does that represent all the voters in the U.S.? No, it's getting worse and worse and worse because at least half of the voters in the U.S. don't even have landlines anymore. So that's part of the problem with the polls, and why polling is such an expensive and complicated business, is because the old way they used to do it by calling people up on their landlines just doesn't work anymore. So that is something that you cannot do simple random sampling on. It's not effective because we can't identify all members of the population. So in simple random sampling, we have to identify all members of the population, and every member has an equal likelihood of being selected. We're not going through the phone book and picking the first person on every page, because there might be some characteristic that is common to all the first people on the page that's not common to everybody else. That's a bias selection. We're truly random in our selection. So, like you did in your exercises, a random sample might look like this. Number one, we'd get all three of the colors from Reese's Pieces, mostly yellows and oranges, and one little brown guy. Now, sample number two, we get a little brown, more represented, orange, less represented. Sample number three, we only got oranges, which is possible with a random sampling. So random sampling is good, in the sense that it minimizes bias. That's the valuable thing about random sampling. It minimizes bias. Why do I keep doing this? The bad thing about random sampling is it doesn't ensure that all groups are represented. So you might ask yourself, how do I do a random sample? Well, in the old days, or if you're just doing all the students in a classroom, real small sample, you can just use a hat. It's like putting numbers in a hat. And I actually do that in real life when it's time to pick our dates for presentation. Numbers in a hat, nobody can see, shake them around, that's a random sample. Lottery balls are another way to do a random sample. And then a third way, which I think is kind of fun, is called a random number generator. And here's a site called random.org. It's appropriately named, where you can use this random number generator you see on the left hand of the screen. You can set your minimum and maximum of people in your sample. So I've got 100 people in my sample. So I want from 1 to 100. I can generate a random number. 29. Okay, number 29 is in my sample. 42 is in my sample. 61 is in my sample. So if I want to get 10 people out of 100, I give out of a population of 100, everybody in the population gets a number, whether they physically get it or they're on a piece of paper, like a list of phone numbers or a list of addresses or a list of classrooms, whatever I'm doing, I number them, and then I can use a random number generator to pick the number that's in my sample. Now, and if you have time, I encourage that you read this page. It's really, really interesting, and it kind of addresses my pet peeve. My pet peeve, and I guarantee you, someone in the class is going to do this pet peeve in their sample, because I talk about this every year, and every year somebody's class project uses the word random in their sample when they're not truly. So when we talk about random in research, it's a specific meaning of the word, truly random. There is no way, shape, or form that there's any pattern to drawing these names or drawing that sample. However, in real life, and especially if you're from California and you grew up in the 80s like I did, you just say random, oh, that's so random, or what a rando, or whatever. You use that word in conversation a lot. And it's often come to represent just something that's kind of weird or unusual. Well, that's random. That's not how we use it in science. It's science that has to be truly random. There's absolutely no pattern. So in papers, I'll read such things as, we randomly walked up to people and asked them to be in our study. That's not random. First of all, I'd like to see how you randomly walk, but that's a whole different study. That's not random. Random is truly without a pattern. So don't forget that. I bet someone will. Okay, so that's how we sample randomly, truly random. And random sampling has an advantage. It minimizes bias. It can get rid of, or to the best we can, sampling bias. But if you think about it, it's really hard to exactly do in real life, because it's difficult that we can identify all members of a population. But we do the best that we can to approximate that. Okay, so that's the first type of sampling. The second type is stratified sampling. Because if you remember, one of the weaknesses, or the weakness I identified in simple random sampling, is that there's no guarantee you're going to get all groups of study. So in the coronavirus vaccine, we want to make sure that it works for people of every skin color, people of every diet type. So we need to sample very carefully and then make sure some people of every group we can think of are in our sample. So in that case, we divide everybody into groups first. And that's called stratified sampling. We divide the population to segments, which are strata. And you can see here that I've divided all the yellow candies, all the orange candies, and all the brown candies into groups. And then we randomly sample from each strata. So within each strata, we take a random sample, but the whole sample is not truly random because we've got people from each strata represented. So I randomly draw 2 people from the yellow group, 2 people from the orange group, 2 people from the brown group. I've identified all groups. So that's a huge advantage. Now, a disadvantage of this, and I thought I put this on the slide, but I guess I didn't. A disadvantage of this is, and I want you guys to look at this for a second and see if you can figure it out. What is wrong with this picture? You're right. I know you all said the right answer out loud and perfectly. I heard you. There's a lot more orange people in the population than there is in the sample. So the advantage is that it includes all groups, but the disadvantage is the groups are not proportionately represented. For it to be a perfect sample, the groups would be the best we can do towards a perfect sample, the groups would be represented in the sample as the same proportions they are in the population. So that's why sometimes stratified sampling is enough if it doesn't matter to our sample that it's in exact proportion, we'll take it. But if we cannot, it doesn't work for our population, if it's really important that the groups are proportionate, we'll move up onto the third type of sampling, which is proportionate sampling. And that's when the proportion of subject samples from each stratum is matched to the proportion of subjects in the population. So I'll say that again. Proportionate sampling is when there's a match between the percentage of people in the population with the percentage of the same people in the sample. Or actually, I'm not going to use people. I think it'd be more accurate for me to say characteristics. So proportionate sampling is when the characteristics of the people in the sample occur at the same proportions that they do in the population. And here's an example, and you're going to want to pay attention to the relationship between the enrollment percentage and the sample size. So let's say I want to do another study on whether to put a fence around the Manoa campus. And I want to make sure that every viewpoint of every class in the population of students is represented. So in this case, I would go to the registrar and I would ask for the percentage of the percentage of undergraduates on campus I want to know how many are freshmen, how many are sophomores, how many are juniors, and how many more seniors. And they would probably give me a number, numbers like this one: 34% freshmen, 26% sophomores, 22% juniors, and 18% seniors. And honestly, this is just a side note, those numbers are kind of sad to me because, and they represent what we normally see in enrollment on any university, is because people drop out. So the freshman class is always the biggest class, and the senior class is always the smallest because people drop out, which is really sad because if you've gotten so close to your degree, don't quit. And I, just as a personal note, my grandpa did that. He was 2 classes short of his degree and he never got it, and he regretted it his whole life. So he would always do anything he could to make sure we stayed in school. So don't regret it, stay in school. And now for that public message, I'll go on to the lecture. We've got 50 people in our sample. So if we have 34% of the population is freshmen, 34% of our sample size, 34% of 50 is 17. We got to get 17 people in our sample. 26% of 50, we've got 26 sophomores, so we've got 13 people in our sample. 22% for juniors, 20% 50 is 11, and then 18% seniors, and 18% of 50 is 9. So in this case, we have what's called a proportionate sampling. Each strata in the population is represented as the same percentage in the population as they are in the sample. And the advantage, which I gave to you early, spoiled the surprise for this slide, is that we've got proportionate representation of each group in my sample. And that can be very, very helpful for some questions. And it's still probability sampling because out of each group, I randomly sample. So out of all the freshmen, I randomly sample 17. Out of all the sophomores, I randomly sample 13. So that last pick, after I set my strata and I set how many I'm going to pick from each sample, it's still random. And the advantage of that is all of my groups are represented proportionately. And the very last type I'm going to talk about, and if anybody cares, this is Massachusetts, I believe, is called cluster sampling. And that's when naturally occurring groups are randomly selected for inclusion in the sample. So you would randomly sample clusters and then include all units within the clusters. So let's say, for example, that I'm interested in 4th grade reading performance in the state of Massachusetts. But I really, really don't want to give a reading test to all 4th graders in the state of Massachusetts. So what I do is I take a list of all the counties and I randomly select 3 counties. Those are those red ones. So I randomly select 3 counties to be in my study. And then actually that's 4, huh? I can do statistics, but I can't do math. That's 4 red counties there. I randomly select those 4 counties, and then I sample all the 4th graders within each of those counties. So that is really useful when we have a really big job to study. It might be helpful to take all the naturally occurring groups that we have and the level of random selection is at the group, then I do everybody within the group. So that can be used for counties, it can be used for school districts, it can be used for church, parish populations. There's a lot of naturally occurring groups that we can use that can be helpful to minimize the job of random selection when we've got big studies. That's just a technique. It's got its strengths and weaknesses because we might have chosen, 3 very rural counties or whatever. In that case, we might want to stratify by rural or urban. I mean, there's ways you can combine these methods, but it helps. It's a lot better than just, picking the 4th graders I know, because that doesn't really help very much because all the fourth graders I know are little geniuses. So that's it, the 4 types of sampling. Simple, random, stratified, proportionate, and cluster. SSPC, I guess. You can remember it however you want. So that's the end of probability sampling. So I will return and we'll finish off the lecture with non-probability sampling. See you in a bit.